you have to cut that bird's mouth so that it planes out with the rest of the rafters on the top. We try to take the wood out of the wall and put in insulation. That changes depending on how you apply the stress in relation to the grain direction. Welcome everybody again to the Bungalows for Bachelors Late Night Learning Live. If you liked that introduction music, you ought to check out the Green Observer, because man, does that guy know how to write some bomb music, and he does everything custom for the Bungalows for Bachelors channel. And so if you want to hear what he can do, just check out some of the videos on my channel, and you will hopefully get an ear for it. And yeah, check him out at Green Observer on YouTube. That's never good. How's the mic now? Let me make sure my audio is good. Put a 2 in the chat if my mic is better. I'm having some internet glitches right now. Of all times, this is the time for the internet to glitch. Okay. I'm getting a low internet signal. So if it cuts out, then that could be why. But anyways, now that it's unmuted, we do it live, folks. If you like the music, check out the Green Observer, because man, is that guy knows how to write some good music. So if you, man, I got all thrown off there. Yeah, if you want to check out more stuff that Bungalows for Bachelors does, then go ahead and join our community or watch our YouTube channel. Obviously, if you're here, you're watching the YouTube channel, but join the community by going to t.me/BFB success and join the Telegram group, where we have a good time and share lots of good stories. There's also going to be a link in the description below. There should be to that. So if you want to see the other stuff that I do, my body of work is at linktree/Samuel D. Stevenson, if you want to see all the other stuff and projects that I do. Now, some of the stuff that we got coming on here at Bungalows for Bachelors is the home building program. Was something that I had created about 2 years ago. And I am now in the process of producing the condensed home building program, with the premise of taking it, because it's like hours of content. I mean, you got to sit down and have like 20 or 30 hours of time to watch the whole thing. And so I'm condensing it right now into probably there's going to be 5 videos, the whole thing in 5 videos. And it's not going to be like, 20 hours in 5 videos. It's going to be significantly less. I think each one's going to be about 10, 15 minutes. I have released the first one already. And so if you want to go check that out, I just dropped it on the YouTube channel, all for free. And yeah, so if you want to learn about like, hey, how do I build a house? Or like, hey, maybe I'm going to go get a house built for myself and I want to kind of know what's going on, then just go check it all out. It's all free and it's all for you guys. So take a look at that. The other thing that I'm working on is the home design program. That's going to be coming out a little bit after the condensed home building program is done. But the home design program is going to be about how you can approach the design of a home if you are going to possibly get something custom built for yourself, either built by you with your hands, or you're a general contractor, or if you are going to go get a builder to do it. Either way, if you want to know what like you should be walking into with the design of your house, that's going to be about how you can approach that, all the way down to if you want to buy some software and like use it, there's going to be some of that information in there as well. So coming soon to you guys. Now, I have to mention that, green candles are great sometimes and red candles are bad sometimes, but ultimately I'm a believer in the world's first blockchain certificate of deposit, known as Hex. And you guys should check it out. Go to hex.com if you want to learn more. There is also a link in the description. And the one last thing to shout out here is that my brother and I, Mr. Will Stevenson, who's in the chat, shout out to you, Will, in the chat, posting links and stuff. Appreciate you and letting me know that my mic is muted and all this good stuff. We have finished the Brothers Two of Them cookbook, and we're only printing 50. In fact, we have only printed 50. They are in the mail on the way right now. They're going to be hand signed and then shipped to whoever they need to go, maybe hand delivered, depending on where your location is and depending on your logistics. But yeah, it is done. It's probably the best cookbook I've ever seen, simply out of just pure holistic value in terms of the quality of the meals and just all the good stuff that's in it. So if you want a cookbook, you better, pick one out. You better let us know, because we only got 50 and people already wanting them. So, let me know. Hit me up in the Telegram or Instagram or whatever. You know where to find me. So get your hands on one of those. 110% cannot be beat. That is damn right, Mr. Will Stevenson. This is a great cookbook. So let's get into the topic of discussion today. And the topic of discussion today, if you are wondering, has nothing to do with the male reproductive organs. It has everything to do with large steel towers and how our communications infrastructure has been built. And there's some pretty cool stuff that I learned recently, and I'm just here to share with you guys. So we're going to hop right into it. But before we get into the technical information, I want to give you guys a little bit of come along. You're going to come along on this journey with us. All right. So us being Will Stevenson is the other guy in the chat here, and he is the tower climber that got me into it. And yeah, it's a great experience. And if you have never done a really awesome, fun job that pays well, and you just want to go travel the country and do crazy cool stuff, then that's what you should do. And so I'm going to lead right into a few sample videos that I don't know if they ever made it to the internet, but I picked them out from some of my personal stuff. And I'm going to throw them on here, and you guys are going to get to see a little bit of what it's like to get some tower experience. So this first one we're going to go into here is basically my brother and I, Will's up here, and we're on the top of a tower in Las Vegas. And this particular tower, 300-foot tower, I think, and we were de-stacking it, right? So these big steel towers, the guide towers, I'll get into a little bit more about that, but these big towers are anywhere from, and this one was like 300 feet, and they could be 2,000 feet or something like that. And they're assembled in chunks. And there's a word for it. Will could probably drop the word in the chat, because the word is not coming to my mind right now. Sections, I think. And so they're assembled in sections, and basically you just stack one section on top of the other, or destack one section on top of the other. And the process for how that happens, because it's mind-blowing how you can get so high in the sky while doing this. But you're about to see with your own eyes from right on the top of the tower how these sections come off. In this case, we were destacking this one tower, but let's go right into it here. So the yellow part is called the gin pole, and that is it's attached to the tower below us, and it's got a little swivel head on the top that's allowing that tower section to be lowered down to the ground relatively safely. So that's how it happens, you guys. That's how you destack a tower. It's pretty nifty. So that being that, the next thing we're going to go into is one of the fun things that can happen when you are climbing towers and you're up in the sky, right? You're exposed. You can see lots of beautiful views. And every now and then you can actually make some neat friends and stuff. So this is a video we got of a guy riding a paraglider thing right by our tower. So he had a good time, and we had a good time. He waved over to us, and these are just experiences you're not going to get unless you go start climbing towers. So gotta check it out. Okay, Will's answering here in the chat. So he says 30-foot sections. So there you go. That is the length, and that is what they are called. Appreciate that, my brother. Now, that Vegas tower was a little 300-foot tower, and that's cool. But a little taller one we did over in Tennessee was a 1,200-foot tower, and this had 3 arbors on the top, and basically the arbors are basically it's like a triple fork thing. There's 3 sticking out, and on the top of each arm sticking out at the top of the tower is more antennas and more tower. So the video I'm about to show you is my brother Will and our other teammate, whom I won't name for privacy reasons. They were up there, and we were removing some sections of pipe of this line off the top of this thing. Now, keep in mind, this video is looking up. So it looks like they're climbing on a tall thing, but keep in mind, they're climbing on a tall thing 1,200 feet up in the air as well. So let's check this one out here. So between using some ropes and some other attachments and things like that, they're able to lower down these sections of line very slowly and carefully because they're expensive, and we're 1,200 feet in the air. Down with the rope down to me, and that's how we kind of get things down on the ground, is using pulleys and ropes and cables and all kinds of cool stuff. But yeah, keep in mind that like they're up there high on top of that thing. They're way above me, and I'm 1,200 feet off the ground, so it's pretty crazy stuff. It's good stuff, and so we like it, and that's what we do. So I got a little bit more here. This other video I'm going to show you is again back at a Vegas job site. Now, sometimes towers are like you're stacking them, you're destacking them, you're taking an antenna and installing it, you're taking an antenna off, or you're maybe installing a whole new you're building a whole new tower. I mean, who knows what you're doing, right? But sometimes, apparently, people need a tower demolished, and the fastest way to do it, if it's a small enough tower, is just to cut the thing down. And so you might wonder how one can cut a tower down safely, right? Because these things are pretty tall. And so on this particular lot in Vegas, we had an array of 4 individual AM towers, and we had to chop them all down, knock them all down, and it was awesome. Except that it was a pretty big lot, maybe like a half mile square, something like that. And on like this array of 4 towers is spread out across the whole lot. So the towers that are on the ends closest to the corner, like if we cut it down the wrong way or it falls the wrong way, it's going to go into like a bunch of Amazon warehouses and stuff. So we don't want that to happen. So we got to be very careful. But we were very careful, and it went. Let's see. Oh, we got a request from Mr. Will Stevens. If you love me, let me go. Oh man, I can probably share a screen and share that off my Instagram. I don't have that easily accessible in a safe way without like broadcasting my computer to the world. But I will see if I can figure that one out. So this is us in Vegas chopping a tower down. Now I have put the camera on a tripod. I'm not going to stand anywhere near where this thing is coming down, but here goes. One more time. Man, the sound that thing made was just the whipping, the speed that thing was going when it hit the ground. That was pretty crazy. A little fun story about that one is we had I had put a little action camera down where I thought the tower was going to land close to, and of course when we're doing this, we're basically taking a guide tower and we're cutting one of the guys. And so after slacking in all of them, so we're leaning the tower over where we want it to go, and then we're cutting the back one so that it goes down where we want it. But we don't know exactly where it's going to go, if the wind's blowing or whatever. So I had put my little action camera down, and long story short, the tower fell right on it and smashed it to pieces. So we did not actually get a really cool video of that, which is unfortunate, but my phone did survive and we got that video. Now, this last one I'm going to share is one of the most exciting times I've ever been on a tower, and it involves inclement weather. And like this particular job, we barely were able to get up there, finish the thing. And when we were coming down, the storm was rolling right in. And so this was just another one of those times where, you don't quite know how much fun tower working can be until you're up in the sky getting blown around by really crazy wind.
Oh boy, kids.
So that one certainly felt like we were about to get, randomly shocked by lightning or something. Luckily, we did not. The rain did come a pouring down basically right when we got to the ground. And it was really great. That was an awesome experience. So, yeah, that was a good time. And so if you guys thought that was pretty darn cool, then you should just go do it. Cause like, there's nothing like it. So we're always looking for people who are willing to climb a tower. Now, now that you've kind of like seen a little bit of like what it's like, we're going to talk a little bit about some of the science and the technicals and like the fun, cool stuff that's cool to me, right? Behind what's going on here. So, for everyone who doesn't like presumes, I'm going to presume you know nothing about towers, right? We drive by them on the highway and like, oh look, that's kind of a thing that's standing up tall, like whatever. Okay, so there's two types. There are self-supporting towers and there are guide towers. Guys refer to the cables that are running like far away from the tower on the ground, and they run up and they like attach to the tower. So there's like sometimes there's multiple anchors and multiple guys and all kinds of stuff. But like those are guide towers. The guide towers are going to be really skinny and they're just going to go straight up. And then the self-supporting towers are going to be generally wider at the base and they're going to taper as they go up. So those are the two types. Now, generally speaking, for the same height tower, if you want to build, if you're going to go build a communications tower and you want to do it economically, then you should probably select a guide tower because on average, they're going to be cheaper. You got less steel. It's less to construct. It's just a bunch of stacked like sections and then a bunch of cables hooked up to it. So it's a pretty economical solution. The disadvantage is that in order for it to make sense, you have to have a wide, large piece of property because those guys, all those cables have to go out and stretch really far out away from the tower. And so if you don't have the land, you might not be able to do it. Now, sometimes people can have weird shaped lots and stuff like that. And there are cases where a tower company will come out and want to build a tower and they'll actually contact the people that live in the area if they want to run a guy or an anchor out on their property. And people can actually sell rights to their property called an easement. And they're dedicating like a portion of that land, like 10 feet, 25 feet wide or whatever, along the guy for the purposes of that tower. So basically it allows people to come out and work on that spot and everything. But anyway, there's guide towers, anchor, and self-supporting towers. So the brain fart here. Get right back into it here. So design approach of each type of tower. So here at Bungalows for Bachelors, we do talk a little bit about the nerdy stuff. And so if we're going to think about the design approach of these two types of towers, one of them, the self-supporting tower, is basically, it's this big, wide, fat thing on the bottom. And it's plopped on the ground and then it tapers as it goes up. You're imagining that? Okay, so there's two loads that a tower is going to handle. It's going to handle its own weight, gravity load, right? The weight of the structure. And then it's going to have all the stuff attached to the structure that weighs something. So it's trying to hold that up too. And then what's going to happen is the tower, depending on where it is in the country, can also accumulate ice because it's very cold up on towers. So it can accumulate a lot of ice weight. And that is extra weight that the tower must support as well. Typically, if a tower is going to fall down and it was under designed, oh, that's really unfortunate. How can I fix that? There we go. Typically, if a tower is going to fall down, it's because there's an unanticipated amount of ice and some crazy thing happens and it's just too much weight. Now, that is for a self-supporting tower. So if those are the weights that it's holding. It's also, it's going to be also experiencing wind load. So when the tower is standing up nice and tall, the wind is going to be blowing back and forth and doing all kinds of stuff. And because these towers are so high off the ground, they are very exposed to the wind. And if you don't know much about wind, it is drastically slower at ground level. And the higher you go up in the sky, the faster the wind can go. It's not impeded by anything. It can just flow nice and smooth and straight. So basically towers, when they're getting blown by wind, they're all trying to get knocked over. That's what's trying to happen. And so these self-supporting towers are basically what they call a cantilevered space truss, which is a really cool name for something that's like anchored on the bottom. And the only place you're holding on is the bottom. And so everything happening on the bottom has to resist this thing that's going on versus a guide tower where you've got this big, long tower going up. It's got to resist all the same loads and everything. But instead of just holding it on the bottom, you're basically holding it in the middle. You're holding it at the top because every place you've connected the guy wire down and like it's anchored to the ground is a place where it will resist that load. And so guide towers are inherently safer from a design perspective because when you attach a bunch of guys in a bunch of places, there's a bunch of load sharing going on in a much more dynamic system. So that's what we got going on. Oh man, we got a pop in chat. Let me check this out here. So we got, shout out to all these people coming up here. We got Connie. Hello, Connie. Welcome to the Bungalows for Bachelors live stream. We got Jenna. Hello, Jenna. Welcome. Glad you're here to learn about towers. That is a excellent choice. And then, of course, we got Tam Tam. Hey, Tam. How's it going? Hope everything is going well. Now, let's get right back into it. So we're talking about the wind loads and ice and all this nerdy stuff. What are some more practical things about towers? Well, they're really high in the sky, right? And people who fly planes generally don't like to hit stuff when they're flying their planes. And so there's a rule made where you got to paint the tower with some I think they call it international orange, I believe is the color. It's got to be international. It looks red, international orange and white. And you got to stagger that so it becomes more visually obvious that it's there. It's not going to blend in with the blue sky or whatever the stuff pilots see when they're up in the sky. I suppose I would know because I've been up that high and looking around. Yeah, I guess so. Some towers are just kind of gray. So I'm not sure what that's about, but they all have to have either the painting and the lights that flash, people don't hit them. But anyway, you don't want to hit stuff when you're flying planes. So that's an important thing that towers need to have. Now, the other thing that you should think about when you're walking onto a tower site is you walk up to the base of the tower, which is sometimes the base at the bottom of the tower. Sometimes it's up there. Sometimes it's even higher, depending on what's going on. But if you walk up with your buddy and you say, "Hey, buddy, we're gonna go up the tower. Shall we take the stairs?" And he's like, "No, I'd rather take an elevator." And so, just like skyscrapers have elevators, towers can have elevators too, because sometimes it's worth it to have a built-in structure that can allow you to pick somebody up the tower and bring someone back down the tower. It's more expensive to install in the first place, and there are some complications. But it's kind of a convenient thing to have. When you don't have an elevator, then the people who have to do any work on the tower have to climb a ladder. And those ladders aren't nice little house ladders that have an angle and they're comfortable to climb and they go up 10 feet off the ground. Nah, these are steel ladders that go straight up for 1,200 feet. And so it's a good workout to climb a tower. It'll take you, a few hours depending on how tall the tower is. So yeah, not always convenient, but hey, sometimes they have elevators, which is cool. So what can cause, so we talked about how the wind blows on towers and ice can build up on towers. And here's a real kick in the pants is that when you have a tower and you built it and it's tall and it you designed it for wind load and everything, and then it gets some ice and that's cool. But here's the real problem is that when you get ice build up on the tower, now the wind load is worse. And you're like, how is the wind load worse just because there's ice on the tower? And it has everything to do with the fact that wind and wind loads are a function of how the air blows over an object. So just like that if you buy a Toyota Camry and you drive it down the highway, it's probably going to be a pretty efficient aerodynamic car shape. And so it's going to flow through the air better. Therefore, the wind will put less of a load on the car, trying to slow the car down. Versus if you drive a bus, that's just a big rectangle. That's a big thing and it's not aerodynamically shaped at all. So it's going to resist more. The wind is going to push on it harder. Same thing with a tower. If it builds up ice load, sometimes there's a whole bunch of coax cables and stuff going up a tower. If they're kind of close together and the wind would ordinarily blow through them, but they build up with ice and they become connected and now it's a big flat thing of it can get so much worse. And so that's something that, is good to know about. So towers are going to get they got the weight pulling it down. They got the ice pulling it down. They got the wind trying to blow it over sideways, but they also have the wind trying to twist the tower. And that is an interesting thing because towers are, they're big, long, twisty things, right? So they're going to flex somewhat. But what makes it interesting is that towers aren't just there to be towers. They're supposed to have stuff on them, right? So when you take a blank empty tower and you install a 10-foot flat dish on the side of it and you anchor it onto the tower, now all of a sudden when the wind blows in a certain direction, it's going to catch that dish like a sail and it's actually going to try to twist the tower. And so when you have, it's okay. It sounds scary, but they're designed for this. In fact, there are ways to get around that. So typically, as soon as you start introducing very large torsional loads, is what we call those, then we do a few things. First of all, on a self-supporting tower, everything just kind of is what it is and designed for like a very specific placement of everything. Excuse me. But on a guide tower, let's say we have a tower that's like 300 feet tall, and every 100 feet there's a guy connection. So there will be one anchor out on the ground, and there's a wire running to the top, a wire running to 200 feet, and a wire running to 100 feet. Okay, so there's three guy like sections, 3 guy connections. So if you do that, then you have 100 feet of tower between guys. Now, maybe that's totally like mathematically unrealistic and whatever, but like for the purposes of the example, if we take the dish and we install it in the middle between 2 guy spans, then like that's actually the worst possible thing. And you really like shouldn't do that. The best place to put and mount this equipment is right above a guy span. If you put it right below the guy span, typically what happens is the signal that's being sent out from whatever you're doing or received is going to get like muddled up in the guy wires that are like really close by. So you want it above a guy connection and close to the guy connection, because the farther you get away from it, the more it's going to be able to twist the tower. And we don't want that. So torsional loads, got to keep in mind. Towers, especially like the skinny ones, the guy towers, right? There's not much in the structure that can resist the twisting. And I'm not prepared to draw anything for you today, but basically imagine if you're going to look at the tower from the top down, right? And that's the tower. You're going to have guys going out in 3 different directions, like a Y shape, right? And so when you try to twist the tower, if those guys, the lines of the guy wires are going straight into the center of that tower, there is pretty much nothing resisting this thing from twisting, because all of those wires are connected in line with the axis of the tower. Now, the way we get around that is if you're going to install just one dish or one small thing on the tower, and the tower is not going to be designed for anything else, then typically what they'll do is in that one spot where that dish thing is connected, they will actually make a metal frame that comes out of the tower, and they will attach the guys to that. And then they will basically like double the guys out in different directions. And so what that does is it puts the guy wire the direction of the guy wire is not in line with the axis of the tower. And what that does is allows to produce like a nice torque arm on the tower, so those wires can resist the twisting. So that's the thing that they're doing. Now, in Vegas, I'm pretty sure there was only, maybe Will can correct me, I'm pretty sure there was only 1 anchor for each set of guys. Yeah, that's correct. It was a pretty small tower. So if you need to be cutting down a tower for whatever reason, it's a lot easier if it's only got 1 guy anchor, because what's going to happen is, oh, he says correct. Oh, thank you, brother. So if you're going to cut that down, you're going to want to slack like all of the guy wires and tighten up. Well, you're going to slack one of them and tighten up the other 2 in order to pull the tower over and lean it in a certain direction. And if there's only 1 anchor on the backside of that tower, you cut that 1 anchor, it's going to go. And it's all going to go at once in one straight line. That's kind of the cleanest way to do it. However, if you're in a place like you're going to build this tower next to a school, or you got to build a tower next to some like important building, and of course these things are really tall, right? They're going really, really high in the sky, and therefore if they fall and they go all the way like the length of like the height of the tower, that's a long reach, and that could easily fall on a school building and totally destroy it. Like, these things have a lot of weight on them, especially when they get that tall. There's no joke. And so one of the things that can be done when you're designing those guide towers is you can actually specifically anchor multiple places for your guy spans. And what that does is, for whatever reason, should one of the guy spans fail on the first set of anchors, all of those wires go slack to anchor to that point. But all of the other guys connected to the second set of anchors or the third set of anchors, when I say anchor, I mean like a big fat block of concrete embedded in the ground, right? That's holding it down. So if you got multiple sets of anchors, it's going to restrain the tower, even as like the top part of the tower might fall. And so if you have multiple sets and the tower falls and collapses, it's more likely to fold on itself and come down to the ground straighter than like fall in a big straight line and go like way out far away and like kill people. And that would be sad and stuff. So yeah, so we try to avoid that. Now, the other cool thing is people had to figure out, okay, well, we're going to start building towers. What materials are we going to use? And steel is pretty convenient because it's pretty cheap and it could be galvanized and it's pretty, resistant and all that stuff. And some people tried using high strength steels in order to reduce weight, but it was turned out to not be economical just because it just didn't make sense and it was complicated. So the other thing they had to figure out was all right, we're going to make it out of steel, but what shapes are we going to use to make the tower? And you ought to know that there are actually a wide variety of shapes and stuff people use when welding tubes and stuff together to make these towers. Typically, it's the legs of the tower. If we're talking about a guide tower, typically the legs are going to be round. If it's a self-supporting tower, typically it's going to be whatever is the most convenient for wherever it's being manufactured. And it's going to be a lot of angle iron and stuff like that. But the round tubes of the guide towers that are super duper tall, there's a lot of benefits to that. The first thing is that a round tube experiences only about 60% of the wind load that a square tube experiences. So if you made each of the three legs a square tube, then you would have way more wind resistance and you'd have to have more strength and more, right? And that's complicated. So we don't want that. So we use round tubes. And so they're more aerodynamically efficient. And there's a little bit of a drawback to using the round tubes. And for anyone out there in the chats who's ever had to weld a round tube to another round tube at any odd angle, it's a nightmare. And so what they do to make the assembly and all this stuff easier, because the big towers are not it's not all welded connections. There's a bunch of bolts and a bunch of hardware and a whole bunch of stuff. And so to make this assemblable, the round tubes need plates installed on them and all kinds of stuff. So we can bolt stuff on with flat plate. And so that adds a little bit of cost, but it ends up making up for it. So round tubes, guys, it's pretty cool. Now we talked a little bit about the types of loads and stuff on towers. And here's the real kick in the pants for the guide towers that people don't think about. And this is going to involve a little bit of understanding of statics to try to make this clear, but I'm going to try to make it a little bit easier. So if I have a tower and it's got wires connected along the tower, pulling it back down to the ground in order to keep it from moving this way. Now, in a perfect world, you'd have a guide tower where it's sitting up and the wires hold on up here and they just go infinitely out horizontally and it keeps it from moving. However, that's the sky and we can't anchor the tower. We can't anchor the wires in the sky. That doesn't work. So we got to bring them back down to the ground. So generally speaking, the farther out you go, the easier that gets. Cause if if you were to go thousands of miles out, that would be really close to you're getting closer to approximating horizontal. But we don't do that because that'd be a lot of wire. And gravity would cause all kinds of other problems. And we don't want that. So what we do is we have to pick a spot that's somewhat reasonable. And it turns out reasonable is about a 45-degree angle down from the top out to the side. Now, because you're doing that and you're using these guys to hold this thing from moving this way, there has to be some tension on that thing in order to move it. Otherwise, if you just let it be floppy and slack, the tower could actually move and then the tension would be taken up and then it would come tight. If you ever pulled a car with a strap or anything like that, and you see what happens when something is not tight and then it comes tight, that's a bad idea. And it can cause a lot of problems. So the wires are tight. And so they're basically constantly pulling the tower in terms of X and Y, it's pulling in two directions, right? Well, it's really pulling in one direction, but we're going to take the force and we're going to cut it up into a Y factor and an X factor. Okay. Some vector analysis here. So if I got the tower and the cable's pulling it down and at an angle, there is a part of the cable that is trying to pull the tower straight down. And there's a part of the cable that's trying to pull the tower straight over. That's all I mean. Okay. And so the part that keeps the tower from going straight over is the part we like. The part that pulls the tower down, we don't like. And we don't like that because that makes the tower have to resist more load. Now there's not just weight of all the stuff on the tower. Now all of these guys are pulling the tower down into the ground. It's come on, get in the ground. And so, that makes the tower have to be stronger, cost more, all yada, yada, yada. So the real kick in the pants is not only is that happening and it's tower's got to hold it, but if the wind blows on the tower sideways, guess what happens? That's right. You guessed it. I know all of you guessed it. What happens when the wind blows sideways is that the tower wants to move over. And when the tower wants to move over, guess what happens to the guy wire on this side of the tower? It gets tighter. It experiences more tension. And you know what happens when this gets tighter is it pulls on the tower harder. And so what we call that axial load in the tower that's trying to squish and compress the tower, the axial load in the tower gets worse when the wind blows on the tower. Like, how inconvenient is that? Like, it's not just like we're designing the tower for wind and torsion and stuff. It's like, well, now it's like all these other crazy factors. And so now if you got ice on the tower and then the wind blows and it's worse because of the ice, and it's worse because there's ice all over your guy cables, which makes them heavier, which makes them tighter. It's just like this big nightmare of all things making everything worse. And then, worst case scenario, like a tower falls down. But hey, most of the time it doesn't. So yeah, those are some pretty cool stuff. Now, there is another cool thing about guy towers. When these wires, I say wires, sometimes they're like, pretty big. These guy wires, they're very long. And on a regular FM tower or something, there are what's called aeolian vibrations. And I'm pretty sure most of you are familiar with what happens with aeolian vibrations. You may not know it by the name, but if you've ever seen the Tacoma Narrows Bridge Galloping Gertie dance on YouTube or whatever, then you will know what I'm talking about. Basically, what happens is everything in the world that exists that has mass has a resonating frequency. And so my arm, if I happen to hit it at just the right place, just the right time, just the right frequency, whatever, it would actually amplify itself and eventually, explode and shatter. And that would be bad. And so what happened with the Galloping Gertie Bridge in Tacoma was that the wind was blowing over the bridge at just the right speed, just the right angle, that it was able to produce a lot of pressures on the bridge. Is a big, massive structure, right? So it's going to feel the wind force. And so it was able to push the bridge in just the right way that it was able to start resonating. And the bridge started resonating at the bridge's frequency. And it was very slow because it was a very big, heavy thing. Thank you, Will, for linking that. Yeah. So the Galloping Gertie Bridge doing this twisting thing. So everything has a resonating frequency, and so do guy wires. And so does everything else on the tower. But the guy wires are typically the most the most susceptible piece of the tower to this problem. And what's going to happen is, as the wind blows over these guy wires, if it hits that aeolian vibration, the wires they'll actually start to vibrate. And they'll vibrate so much that they'll actually start to vibrate the tower, and they can break stuff on the tower. And wind just causes a big, terrible mess. And so what happens is, to avoid that, they take these things called dampers, and the dampers are installed at the anchor, and they are designed in such a way to absorb those vibrations and not let them build up. So that just becomes not a problem. So that's how we stay out of those aeolian vibrations. Not to be confused with fallopian vibrations. Those are a little bit different. So let's talk a little bit about foundations, guys. I know we talked about the towers, and those are cool, but the foundations of towers are also very interesting. Now, self-supporting towers, not that complicated because it's just a big thing and it's sitting on a big block of concrete, and that's a foundation. That's what foundations do. But the interesting thing about guide tower foundations is the design approach. It's a little bit different. Now, at the center where the tower sits, that's pretty much the same. It's a block of concrete in the ground. It's spreading out a massive load from a tower that's coming straight down and putting that load into the earth, and it's just trying to not sink into the earth, right? So that's what it does. But the anchors have foundations too. They have big blocks of concrete. And what's super unique about those, excuse me, I have a lot of burps, is, wow, it's pretty much the only foundation that's ever going to experience significant, its only load type is up and out of the ground. Pretty much all other foundations have loads that are pushing them down into the ground, so it's not a big deal. But for a guy anchor, like these things, I don't know the numbers of the tension, but there's thousands of pounds of tension in these cables. And so you got this big block of concrete embedded in the ground, and everything is trying to pull it up out of the ground and move it over sideways. So not only do you have to design for, like, okay, the block of concrete has to be heavy enough that it doesn't come out of the ground, but also the type of soil that like the foundation is in has to be able to resist the thing trying to move sideways, right? There's some component of that guy wire force that's going to try to pull the block sideways in the ground. And so it actually not only has to be able to resist the like downward weight of everything, but it has to be able to not slide. And the real trick is when you're installing and building anchors in like places with a high water table, then what happens is you actually have to like check your numbers a little bit differently. Because if you put this big, massive 10 foot by 10 foot by 10 foot block of concrete in the ground, and the water table is like at 2 feet below the surface of the ground, then what's actually happening is the mass of the water at that, like, which is basically 8 feet of the concrete footing, is creating a buoyant force on that concrete. So the concrete's actually trying to float. It's heavy enough that it won't, but you do have to keep like in mind that like if you're relying on the weight of the concrete to do its job, then it has to be heavy enough to overcome the fact that there's also a water buoyant force on it trying to lift it up out of the ground. It's just crazy cool stuff. So foundations can be very complicated. And yeah, you want to make sure that they're anchored really well. All right, last thing I'll talk about before I'm going to pick one of these. Maybe the tower falling one. Actually, we got some I'll do the tower falling one again. But the last thing to talk about is lightning, right? Lightning and storms. So for people that work on towers, like you don't really want to be up on a tower when there's a storm, both because there's a ridiculous amount of wind. Like it's hard enough to work when it's just windy, because most people don't know what it's like to work outside, first of all, and to work outside in really high wind. Like it doesn't feel like a lot, but like you get into 30 and 40 and 50 mile an hour, and it's like you're up there, you're holding a bunch of, like, you got a drill and you got a wrench and you got a thing, and you're trying to like carefully undo bolts out of this like flange and like not drop the nut, because if you drop the nut, it's going to fall 1,000 feet and then like put a hole in someone's head. And you're just like, you got all this stuff going on, and like the wind's blowing your body around at like 50 miles an hour, and you're just trying to focus and you're trying to listen to a podcast about like how the mind works and who knows what. And so it's crazy good fun. And so you just got to watch out for storms. If there is like a lightning storm or something like that, typically there's all kinds of special lightning arresters on the tower that attract the lightning and channel it down to the ground. And so if you happen to be in one, you want to be on the inside of the tower, and hopefully it's not like a 1 foot or a 2 foot wide tower where you can't get on the inside. Otherwise you become the lightning conductor. But yeah, we try to avoid that. So that's some neat stuff about towers. I'll go ahead and bring up this tower falling video one more time. Let's see. This is the right one here. Okay. And again. There we go. So that is it, guys. That's my download on you. I ran across a book. Honestly, I was being curious. And when I get curious about engineering stuff, I'll just go read an engineering book. And I was like, you know what? I don't know a lot about towers. And so I checked it out and downloaded on you guys. So now you know too. And anyone else will know if they watch this after live. So thank you all for coming. Let's do one more chat run through here. So we got Tam Tam. We got Jenna. We got Mr. Will Stevenson. It's good to see you guys having a good chat going on here. Oh, yeah, we do have chicks in the chat. We do have a lot of chicks in the chat today. Shout out to all you chicks in the chat. I like it. I could get used to this. Okay, what else? There was Connie in here somewhere. I know she's in here. There she is. Hello, Connie. There's an emoji for you guys. I hope you guys have had a good time and learned something. Thank you for coming on and supporting this channel and the show and helping that algorithm out. I will think of something clever to do next week, and hopefully you come back because you want to learn more, and that's what we do here. So I will see you guys next week. hopefully.